Example 5, again from 16a. Find the equation of the tangent to y equals tan x at the point where x equals pi over 4. Okay, so again, let's decode our information. The point where x equals pi over 4. This is our point of contact when x equals pi over 4. So what is the y-coordinate at that point? So y equals tan of pi over 4. That's the same as saying sine of pi over 4 divided by cos of pi over 4. Okay, but remembering one of our rules here, tan x equals sine x over cos x. Now we need to also remember the unit circle. Pi over 4 is 45 degrees, so we also have 60 and 30 degrees. This is pretty messy, but those of you that I taught may remember this quick and easy way of remembering the unit circle. Let's do that a little bigger over here. In the first quadrant of the unit circle, we have these three angles. Of course, the angles are pi over 6, pi over 4, and pi over 3. Okay, from the initial ray up to each terminal ray. The equivalent here is 30 degrees, 45 degrees, 60 degrees. And a quick, easy way, remembering that as we travel on the x-axis, these ordered pairs for the x-coordinate get larger, so I'm going to say 1, 2, 3. As we travel on the y-axis, the y-coordinates get larger, so 1, 2, 3. But they're not just 1, 2s, and 3s. They're root 3 over 2, 1/2, root 2 over 2, root 2 over 2, 1/2, and root 3 over 3. And those are your ordered pairs for those 3 points in our first quadrant. All right. So sine of pi over 4 divided by cos of pi over 4, then sine of pi over 4. Pi over 4 is here. Sine is the y-coordinate, so that's y root 2 over 2. And cos is the x-coordinate, so root 2 over 2. That is equal to 1. Therefore, our point of contact is actually pi over 4, 1. All right, we're looking for the equation of the tangent line. Here is our function. So we take the derivative of that function, which we can remember is cos squared x. Another little aside, just to remind you, cos squared x is actually the same thing as cos x all squared. Okay, but this is the proper notation. But just so you have it in your head that it actually means this thing. Okay, those are the same. Another little thought bubble. So now we need to determine the gradient of the tangent at pi over 4, 1, which we can do by substituting this x-coordinate into here. So dy dx equals 1 over cos squared pi over 4, which is actually the same thing, thinking about this guy, same thing as 1 over cos pi over 4 squared. Okay, and it's okay to use that notation at this point. Cos pi over 4, we already found out, is root 2 over 2. So that's 1 over root 2 over 2 squared. 1 over root 2 squared is 2. 2 squared is 4. 1 over 1/2, which is 2. Okay, so the slope is 2. The gradient of the tangent line is 2. So y equals mx plus b. Slope is 2. We can fill that in. We have a point of contact here, so we can fill that in and solve for the y-intercept. And the y-intercept is 1 subtract pi over 2. Or if you want it that all as one fraction, you could say 2 subtract pi over 2. Those are the same thing. Therefore, the equation is y equals, slope was 2, 2x, plus 1 minus pi over 2. So 2x plus 1 subtract pi over 2.